Okay, so today we're going to do a bit of revision on our magnetism and electromagnetism topic. So we've thought about our magnets and we've thought about how opposite poles attract and like poles repel. And then we've thought a bit about our magnetic field lines. So thinking about they always point from north to south and then they would kind of go in a semicircle round the magnet. We've also thought about when you run current through a wire, you can then get a magnetic field around it, and we demonstrated that by using our compasses, which are mini magnets. And when we turned the electricity on, so there was a current through the wire, they all pointed in the same circular direction around the wire. And what we also showed was if the current is running pointing upwards, so from positive to negative, going this way, we can use our right-hand corkscrew rule to know which way round the magnetic field is pointing. So this way, if you were looking at it, this way would be going anti-clockwise, and if the current was running the opposite way round, so pointing away from you, it would be going in a clockwise direction. We then thought about our Fleming's left-hand rule. So we had our thumb was the force, our first finger was B, which is our magnetic field, and then we had our middle finger is I, which is the current. And from this, we can think when you've got a current flowing through a wire and you've got a magnetic field pointing from north to south, you then would have a force on the wire pushing it upwards. And if you change the direction of the current so that comes towards you, you would then have the force in the magnetic field change direction. You would have the force in the same direction, or you could flip that round and have the force in the opposite direction. So that lets us know which way the force is going to act. We then thought about the strength of the magnetic field and the strength of the force, and I'll think now about our equation. So we've thought about our Fleming's left-hand rule, which talks about the force that applies on the wire when you've got a magnetic field pointing north to south and you know which way the current is flowing. But now we're going to think about our equation. So if we've got the wire within the magnetic field, we've got to think about the length of wire as well. So we can calculate the force by thinking that that's equal to the magnetic field times by the current times by the length of the wire. I'll just adjust this to show you that equation. So from using our Fleming's left-hand rule, we know we've got our FBI, but we're thinking about the force is going to be equal to the magnetic field times the current times the length of the wire. Force, as with all our forces, like in our forces topic, will be measured in newtons. The magnetic field or magnetic flux density will be measured in Teslas, just like the car company, so that would be a capital T. Current, as you know, would be measured in amps, and length of wire, like all lengths, would be measured in meters.